The next problem says a ball is thrown up with an initial velocity of 2 meters per second. Part A, find its velocity after 0.05 seconds, and part B, find its velocity after 25 seconds. So I'm only going to show you part A. You can do part B for more practice. So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's try to do this one. So the first number I see is 2 meters per second, which is a velocity. And the other number is 0.05 seconds, so that's the time. It's still not a lot of information, so let's see what's happening here. This is the ground. The ball is thrown with initial velocity, and it's in midair. And you're trying to find, after some time t goes by, what is going to be its velocity. So this is in midair, so this is in free fall, so you have to include gravity. So the equation that we want is going to be the velocity of a falling object. So the equation that we're going to use is going to be final velocity minus initial velocity is equal to negative gravity multiplied by time. And we just have to plug in, well actually here then the 2 is the initial velocity. So this is the 2. So now we can plug in. We want the final velocity. Initial velocity is 2 going upwards, so it's positive. So minus a positive 2, and equals negative g, which is negative 9.81, and the time is 0.05. And solving for that, you should get a velocity for part A of 1.51 meters per second. Alright, so now let's try the next one. Here it says a ball is thrown down with an initial velocity of 5 meters per second. How long will it take for the ball, for its velocity to increase by 10 meters per second? So I'll just do part A. So go ahead and pause, try to solve this, and when you're ready, unpause. And also you can do part B for more practice. So just looking at the numbers first, there's a 5 ms, so meters per second is a velocity, and there's a 10 ms, that's another meters per second, so that's another velocity, and it's asking how long, so we're trying to get t. But now let's try to draw a picture to see what's happening here. Let's say you're on a building, you toss the ball down, so initial velocity is going to be at 5, and it's also down, so it should be negative 5. So the initial velocity is going to be negative 5, and sometime t is going to go by, and now the ball's velocity is going to increase to the final velocity, which should be, in this case here, 10, but that is also down, so it'll be negative 10. So the final velocity is going to be at negative 10. And we're trying to find out how much time it takes to travel that distance. So this is, again, a falling object, so we have to include gravity, and we want to get the, and this involves the velocity of a falling object. So it's going to be the same equation. Final velocity minus initial velocity is going to equal negative gravity times time. So we can plug in the final velocity is a negative 10 minus the initial velocity, which is a negative 5, and equals negative 9.81 multiplied by time. So you just have to do some algebra. When you solve for t, you'll get that t should equal, well actually let me clean this up some before I jump around. So this will be minus 10 plus 5 equals negative 9.81 times t. And when you solve for t, this will give you 10 minus 5 over 9.81. And that will come out to be about 0.51 seconds. Alright, so now try this one. Says you have a ball that's dropped from a building and it takes 5 seconds to hit the ground. How tall is the building? So pause, try to solve this, and when you're ready, unpause. Alright, so let's write down the givens. You have 5s, that's the time. And that's it as far as a given, so now let's try to draw a picture of what's happening. So this is the ground, you have a building, you have a ball, starts here, is dropped, it's going to fall, and it's going to take some time t to hit the ground. And you're trying to figure out what is the height y of the building. So because it's falling, this involves gravity. So really the equation that we're going to use is the height of the building, or in this case here, if we take the absolute value, the distance fallen is going to be gravity time squared over 2. And we just have to solve for the height. So then the height is going to be 9.81 multiplied by the time, which is 5 squared over 2. And that should give you about 122.6 meters.